Hi everyone, today we're going to be solving equations using both the addition and multiplication principles that we've been working with. So the first thing we're going to look at is our way to solve our equations. And there are a lot of steps, but they're going to make sense once we start solving. So step one, it tells us to multiply on both sides to clear equations of fractions or decimals. It's optional, but it makes the computations easier. We can always work with fractions. We're going to see that today. Step 2 tells us if parentheses occur, multiply to remove them using the distributive property. We saw that when we were simplifying expressions, so it's going to be the same thing here. 3, collect like terms if necessary. Again, that was something we saw with simplifying expressions. It's just another building block that we need to get to solving equations. Step 4 is to get all terms with variables on one side and all numbers, the constants, on the other side, using the addition principle. We saw that when we were working with solving equations using addition. Step 5 is to collect like terms again if necessary. We'll see if we need to regroup anything. Step 6 is to multiply or divide to solve for the variable using the multiplication principle. And the last thing we need to do is check all possible solutions in the original equation. Whew! That was a lot of steps. Don't worry, we're going to see how all of these kind of flow into one another. So let's go ahead and start with our first examples. I'm going to keep those rules, close by. So if we look at our first example on number 1, we have 3x plus 4 equal to 13. So let's go ahead and solve this. First thing I want to do is separate my left side from my right side. If we notice, we don't have any kind of fractions or decimals to clear. There are no parentheses. We don't have any like terms on one side. So basically we're here on step 4, getting all the terms with variables on one side and all the numbers, the constants on the other side. So we notice that this is a variable term. 4 is a constant, 13 is a constant. So I need to get my constants together. To do that, I need to undo this 4. Well, what will undo a positive 4? A negative 4. Or what will undo adding? Subtracting. So I'm going to go ahead and subtract 4 from both sides. That's going to leave the 3x here. 4 minus 4 is 0, so I'm just going to cross those out. And 13 minus 4 is 9. We don't need to collect terms again, so we can skip step 5. Then step 6 says to multiply or divide to solve for the variable using the multiplication principle. We saw that in the last video. So we have 3x equals to 9. We're going to go ahead and divide both sides by 3. 3 divided by 3 is 1x, or just x, and 9 divided by 3 is 3. So we have solved this equation and x is 3. We are done. Moving on to example 2, we're going to look at this one and solve it very similarly. We have no fractions or decimals, so we don't need to clear. We don't have any parentheses. We don't have any like terms on one side of the equal sign. So we're again on to step 4, which tells us to get all variables on one side and all constants on the other. Since the 6 and the 16 are constants, I want to go ahead and move those together. Because I see a minus 6, the way to undo subtraction is to add 6. And again, whatever I do to one side of an equation, I have to do to the other side. So negative 5 is going to come down. Nothing happened to that. Negative 6 and a positive 6 is 0. And 16 plus 6 is going to be 22. So the next thing we're going to do is multiply. Well, there are no like terms, so we skip step 5. And again, step 6 tells us multiply or divide to solve for the variable using the multiplication principle. So this becomes an equation that we saw when we were working with multiplication principle. And all I'm going to do is go ahead and divide both sides by a negative 5. The negatives will cancel out. 5 divided by 5 is 1x, or just x. And then we have 22 divided by negative 5. Well, we can't simplify this, so I'm just going to go ahead and leave my fraction as negative 22 fifths, as negative 22 fifths. Yes, there we go. I said it right. Since we, again, can't simplify, we are done. And I don't want to take that extra step to make this a mixed number, so that's why I'm going to stop right here. All right, let's look now at example 3. If we look over here at example 3, we have 45 minus m equals 13. I'm going to go ahead and separate my left side from my right side. Again, there's no fractions or decimals to clear. There's no parentheses. There's no like terms on one side. So I'm going to do step 4 again and get all the terms with variables on one side and all the constants on the other. So I know 45 and 13 are my constants, so I'm going to move 45 so that we can get that variable m by itself. So I'm subtracting 45 from both sides. 45 minus 45 is 0. It's gone. I'm left with this negative m equals 13 minus 45 is going to be a negative 32. And we have to remember that the coefficient that we don't see in front of this in front of this m, is that invisible 1. So I'm going to go ahead and draw that there. And now I know I can divide both sides by negative 1 to clear out the coefficients in front of my variable. The negatives are gone. 1 divided by 1 is 1, so it's just 1m or m. A negative divided by a negative we know is positive. We can get rid of those negative signs right there. And 32 divided by 1 is 32. So we're left with m equals 32, and we're done with example 3. Okay, moving on to example 4. This is where things start to get a little bit harder. I'm going to put a star right here on 4 because I'm going to solve this just like we have been. I'm not going to change anything around. Later on, we're going to see the same example again. So the first thing I'm going to do is go ahead and draw my line through my equal sign. There's no parentheses, there's no like terms, so I'm just going to get my constants on one side and my variables on the other. I can see that 16.3 and negative 8.18 belong together. They're both my constants, so I'm going to go ahead and subtract or undo that positive 16.3 with a negative, and I'm going to do the same thing to the right side. 16.3 minus 16.3 is 0. What's left is that negative 7.2y. And then negative 8.18 and negative 16.3, remember our integer rules. We have to when the same signs are the same, we add the two numbers together and keep the sign. So it's going to be a negative, and it will be 24.48, which I'm trying to squeeze in right there, and I made it. Okay, our last step, since we have no more like terms to collect, is to divide both sides by negative 7.2. Oops, guess it would help if I wrote the division there. So the negatives are gone on the left side. 7.2 divided by 7.2 is just 1, so we're left with 1y or y. I don't know why I wrote that y1 there. I'm going to scratch it out. And then we know from our integer division that a negative divided by a negative is going to be a positive, so we can go ahead and cancel those out right there. 24.8 divided by 7.2, decimal division is pretty terrible, but we do end up with y equals 3.4 on that one. So those first 4, not too shabby. Let's look at the next few that we have here. Example 5, we're adding in this step 3 that we haven't seen. Remember, step 3 was collect like terms. We've only been starting here with step 4. Now we're going to come back to 3. So I'm going to go ahead, draw my line right here so I have a different left and right side. I do have like terms 3x plus 4x. We know 3x plus 4x is 7x equals negative 14. Because my variables and my constants are already separated with the equal sign, I don't need to do step 4 and get them all together. I don't need to collect like terms again. I can just go straight to step 6 and divide both sides by 7. 7 divided by 7 is 1, so we're left with 1x or x. A negative 14 divided by a positive 7 is going to be a negative 2. And we're done. Okay, now let's look at step 6, or example 6. Okay, now that we're getting into the larger number examples, they're going to start to be a little bit harder. So if we look here at example 6, first thing I'm going to do is draw my line. We still have no fractions or decimals to clear. We don't have any parentheses. We are on the collect like terms part. We don't have any. So we're back here again at step 4. It just looks a little different than it did on 1, 2, 3, and 4. We have to get all the terms on one side. Notice we have 2 variable terms and 2 constant terms. So I want to get my 2 constants on one side and my 2 variables on the other side. It doesn't make a difference which ones are where. Because I have a negative 3x, I want to kind of get rid of the negatives. I want to make this as easy as possible. So I'm going to add 3x to both sides. We could have subtracted the 2x as well. It would have been the same thing. So we have 2x plus 3x, which is 5x. Nothing happened to that minus 2. Negative 3x and a positive 3x is 0, so that's gone, equals to 3. Now this becomes one of the problems that we were working with before. The next thing I need to do is continue to get my constants by themselves on one side. So I'm going to go ahead and add 2 to both sides here. Nothing happens to the 5x, so I'm just going to bring that down. A negative 2 and a positive 2 is 0. And 3 plus 2 is 5. The last step, since we're not collecting any more like terms, is to divide. So I'm going to divide both of these by 5. 5 divided by 5 is 1x, or x. Again, I did that. 5 divided by 5 is 1, so we now know that x is equal to 1. There, I just made it part of my box. Decorative piece of my box. And the last example we're going to look at here is going to be example 7. So a longer equation that we're working with, but again, we're going to follow the same steps. We still don't have any fractions or decimals to clear. There are still no parentheses. So step 3 says to collect like terms if necessary. It is necessary here, so let's go ahead and do that. On my left side, hopefully we see 6x is like the negative 7x. And on the right side, hopefully we see that 10 is like the 3. So I'm going to go ahead and collect those right now. So 6x plus negative 7x, or 6x minus 7x, is going to be a negative 1x. There was nothing like that 5, so I'm just going to go ahead and bring down the plus 5. 10 plus 3 is 13. Nothing like that minus 4x, so I'm just going to go ahead and bring that down. Then, if we look, we're now on step 4, getting all the variables on one side and all the constants on the other. So I notice that I have a negative 1x and a negative 4x, and I have a positive 5 and a positive 13. Again, it doesn't matter which one we want to move first, where we want to move it to. I'm going to go ahead, since we have this negative 4, I eventually want to end up with a positive x, so I'm going to go ahead and move that. So I'm going to add 4x to both sides. And negative 1x plus 4x is 3x plus 5 equals 13. Negative 4x and a positive 4x is 0. It's gone. Now, I want to go ahead and move that 5. We could have moved the 5 at the same time and done that right here, minus 5, minus 5. I just want to show every single step by step by step. But you can combine steps if you feel comfortable. 5 and a negative 5 is 0. And 13 minus 5 is 8. Okay, the last step is to divide both sides by 3. So we end up with x is equal to 8/3. We don't have any common factors. I don't want to take time to make this a mixed number. So we're done for now.